Hello friends, in today's video we will solve Geeks for Geeks problem of the day, which is replace every element with the least greater element on its right. So we are given an array of n integers and we need to replace every element with the least greater element on the right side of the array, and if there are no greater elements on the right side we would replace it with -1. Okay, so let me take one case which is 2, 6, 9, 1, 3 and 2, right? So this is my input array which is given to me, and I need, for each element I need to find the least greater element on the right side. Okay, so see, for this 2 the least greater element on the right is 3 only, right? So that means this is 3, correct? Now for this 6, what is the least greater element, which is 9. For this 9 there exists no greater element on the right, we need to see on the right side of the array, it is -1, right? For 1 again it is 2. For 3, on the right of 3 there exists no greater element, right? So again -1. And 2, for 2 is the end of the array, so definitely it will be -1 because there exists no element which is towards the right of the 2, right? So this is my answer, and let me verify it once. 3, 9, -1, 2, yeah. So this is my answer, for this case, right? Now the thing is, how would you approach to solve this problem? So generally, when you have something like next smaller element or next greater element on the right, next smaller element or next greater element, right? So we know that we could solve this with the help of stack data structure, right? We already know that. So just a minute. So, yeah, so we could we could then solve it with a stack, right? If it was I would say a kind of say some problem on my end. Yeah. So the case was 2, 6, 9, 1, 3, 2, and generally we solve these problems with the help of stack, right? The next smaller element or next greater element, whether it is next smaller element, next greater element to the right, correct? But here there is one trick, or I would say one catch, that is that we need to find the least greater element, not the next greater element, right? So least greater element, let's say, see, for 2 the next greater element is 6, okay, that is correct. But for 2 the least greater element towards the right is 3, okay. So we need to find out this 3. How would you do that? So this is the thing we need to find out. Means for 2 the smallest element to the right is the smallest element greater than 2 is 3, correct? So there is some kind of I would say binary search type of intuition coming in my mind, like, so how it is binary search or something like that. See, for that you need to think of how would you iterate the array, right? So 2, 6, 9, 1, 3 and 2, correct? So if I start from the rightmost end, right, if I start from the end of the array, now I know that for the last element it would be definitely, my answer would be -1, correct? And at the same time I would append this in my some data structure, or I am taking a unordered set or a set, okay. So I would pushing it in my set, okay. Now for 3 I am checking upper bound, right? This is my data structure, assume it has only one element, right? Because we have started from the right side at the array. Now this is my data structure, I am finding upper bound of 3. Now upper bound of 3 is towards the end, means there is no upper bound of 3 because there exists no element greater than or equal greater than 3, correct? So it is pointing towards the end iterator, right? So then again it is a -1, and at the same time I would append 3, right? So this is, since this is my set data structure, it would automatically sort it, right? It would automatically sort, okay. So that this is the reason I am using set data structure, because I can then use an upper bound function. See, we need to find out the next the least greater element to the right, correct? So upper bound function will be of much help, and upper bound, yeah, on backend it definitely uses a binary search only, right? So this is a, I would say, binary search and set mix problem, okay. So then I can use an upper bound to find out the next greater element, correct? So now for 1, what is the upper bound of 1? Upper bound of 1 will return me 2, correct? So that is also my answer, so 2, correct. Now at the same time I would insert 1, so I would have inserted 1 in the beginning. Now my next element is 9. Now again upper bound of 9 is pointing towards the end of the data structure, that means it is a -1 because there exists no element greater than 9, correct? And yeah, I would definitely insert 9. Then I am at 6, 6, the upper bound of 6 is 9, correct? See, 6 lies somewhere between 3 and 9, and the upper bound function returns the next greater element, right? with the current element of the current element. So it is 9, it would return me 9. Okay, 9 is correct. And again I would insert 6, so I would insert 6 in somewhere in between 3 and 9. Now for 2, the upper bound would return me 3. See, the first let me be clear. Upper bound function returns next greater element. Upper bound function returns next greater element. Okay, so in a sorted array, right, we can only apply upper bound and lower bound and binary search only on sorted arrays or sorted data structures, right? And I know that my set is automatically sorted, right? Set is by default sorted, means yeah, whenever you insert it, it would sort it in ascending order only, right? Unless you specify to be in descending order, correct? So this is my probably the approach to solve this problem. And upper bound, yeah, what I was saying, yeah, sorry, just a minute, again there is some problem. Yeah, so my upper bound function returns the next greater element. Okay, so assume that this is my sorted array. So for 3, upper bound of 3 is 7. Why? Because 7 is the least greater element greater than 3, correct? And similarly for 9 and 10. So for 9, my upper bound is 10. For 10, my upper bound is null, because there exists no element greater than 10. Not greater than or equal to, but as be careful of that, greater than x, right? Greater than the element x. So for 2, my upper bound would be 3. And for 10, there exists no upper bound, hence null, or I would say does not exist. No upper bound exists in my array, correct? So this is the approach. We will solve this problem using this approach, and the time complexity would be big O of n log n, correct? Because we are using a set data structure, then using an upper bound function, right? So for inserting in the stack and for upper bound would take big O of log n time approximately. And yeah, since we are using set, our extra space would be big O of n also, so that be careful of that. And probably in the question also we are told that we can use an extra space of big O of n, and time complexity is n log n, correct? So let me now then go through the code. So we are taking one answer vector, correct? We are taking one set. The main trick is that we need to start from the back end of the array, right? Back of the array. We need to start from the iterating from the back of the array, right? Because then only we will find the next greater element, correct? See, if it was next greater element problem, then we would have started from the back only, right? Then only we could push the element in the stacks, and then we would find the results, correct? So this is the so if my set is empty, then definitely my answer is -1. I would push back -1 for that element, right? And else I would find the upper bound for that element. And if my iterator points to the end, then again it is a -1, because there exists no element greater than that element, correct? And else I would push the value of that iterator, which is star it, and towards the end I would definitely insert all of the elements in my set. And finally, since we are iterating from the reverse end, I need to reverse my answer vector, and then finally return my answer, correct? Let me try to submit it. Yeah, so it is passed all of the cases. I would paste the code in the description. Do not forget to subscribe the channel, because it means a lot for me. And do not forget to like the content also. Okay, thank you for watching.